Good morning, everyone. I am Priyadarshini, working as Assistant Professor in Malareddy Institute of Pharmaceutical Sciences from the Department of Pharmaceutics. And today we are going to discuss about the topic herbal formulations, which has been included in herbal drug technology in third year, second semester for B Pharmacy. So let us discuss about what is a herbal formulation. So herbal formulation, we can say that it is a dosage form which consists of processed herbs or one or more herbs in a particular quantity in order to decrease or diagnose a particular disease or treat a particular disease. So in this herbal formulations, either we can use one herbal constituent or two or more herbal substances. So if we are using two or more herbal substances, that is called as a polyherbal formulation. So let us discuss about the types of herbal formulations. In that, there is 4 types of herbal formulations which have been included in our syllabus. That is herbal syrup, herbal mixtures, tablets and novel dosage forms. In today's video, we will discuss about the novel dosage forms or novel drug delivery systems of herbal formulation in detail. So in that, we can say that phytosomes have been included. And what do you mean by a phytosome? The term phytosomes can be divided into two parts, that is phyto means the plant and some means cell like structure. So phytosomes are cell like structures. Once this is also called as an advanced herbal formulation that contains a bioactive phytoconstituent of herbal extracts surrounded or bound by a phospholipid. So in this phytosomes we are using a phospholipid which consists of hydrophilic head and a hydrophobic tails. So most bioactive constituents are water soluble components such as flavonoids and glycosides. So whatever the phytoconstituents we are taking from the plants, they are mostly water soluble compounds. So because of this the phytosomes will show both the water soluble nature as well as lipophilic outer layer. So based on that, they show a better absorption and improved bioavailability. So let us discuss about the chemical properties of a phytosome. Phytosome is a complex between a natural product, that is the phytoconstituent, and a phospholipid, okay, which is also a natural compound. So the phytosome complex is obtained by reacting an appropriate amount of phospholipid with a substance present in a suitable solvent. So here we can take the solvent such as glycerol. The main phospholipid substrate interaction occurs through the formation of hydrogen bonds between the polar head of the phospholipid and the polar functional groups of the substance. So when this particular phytosomes will be treated with water, they assume a micelle like shape and forms a structure which resembles the liposomes. They are not forming a micelle, they will be forming a micelle like shape. So next, coming to the structure of a phytosome, if you see the structure of a phytosome, it consists of a phospholipid and a drug and as well as the complex. That means what? The phospholipid which consists of a phyto. So if we look at the structure of a phytosome, it consists of a phospholipid with a drug. So this phospholipid and drug will form into a complex. So phospholipid consists of a hydrophilic head and a hydrophobic tail. So this phytoconstituent or the drug which is present will be entrapped within the hydrophilic head. So let us now see the differences between phytosome and a liposome. So phytosome, it consists of the active molecules or active constituent molecules will be attached through the hydrogen bond. That is, a chemical bond will be formed between the polar head of the phospholipid and a phytoconstituent. Whereas in a liposome, there is no bonds which are being formed, but they will be dissolved into the aqueous cavity or incorporated into the lipid membrane. Whereas in phytosome, there will be formation or there will be presence of chemical bonds. In liposomes, no chemical bonds will be present, and the ratio of phosphatidylcholine and plant components will be varying from 1:1 or 2:1 complex. Whereas in the liposomes, the hundreds of thousands of phosphatidylcholine molecules will be surround the water soluble molecule. So phytosomes will show better bioavailability when compared to that of the liposomes, and they require comparatively less phospholipid than that of the liposomes. So let us now see the difference in the structure of liposome and phytosome. So as you are seeing in the image, it shows that the drug is being present or entrapped within the micelle-like structure, micelle in the liposomes, whereas in the phytosome, the drug is forming a complex with the hydrophilic head. The upper part of the image shows the liposome structure, whereas the lower part of the image showing the phytosome complex. So once coming to the advantages, let's discuss the advantages of phytosomes. They are showing a better absorption of the herbal constituents, and the rate of the absorption reduces the required dose, also improved absorption. So phosphatidylcholine acts as a hepatoprotective agent and producing a synergistic effect. So what do you mean by synergistic effect? The presence of one component will enhance the activity of the other component. So better stability profile when compared to that of the normal dosage forms, that is the conventional dosage forms, and ensure proper delivery drug to the targeted tissues. And there is a high entrapment efficiency. Phytosomes are superior to liposomes in skincare products also. Better bioavailability, nutritional benefits, and the drug will be enhanced. The permeation of the drugs is enhanced through the skin. So let us know what are the disadvantages of the phytosomes. In this, the drug loading capacity is quite low when compared to that of the liposomes. Obviously, they are more expensive than that of the liposomes, and decreased stability. So there is a chance of getting oxidation and hydrolysis. So that's the reason the stability of the phytosomes is quite less. Now, other than the API or the active phytoconstituent, we are using other additives, that is the phospholipids and aprotic solvents, non-solvent, and alcohols. So the examples of phospholipids which are being used in the preparation of a phytosome is soya phosphatidylcholine, egg phosphatidylcholine, and the remaining examples are being mentioned. And aprotic solvents, dioxane, acetone, and methylene chloride are being used. So aprotic solvent means which does not contain a OH and NH bonds, so that doesn't donate the proton, so that is called as an aprotic solvent. And non-solvent example is N-hexane. So let us know what are the different methods of preparation of a phytosome. So there are three methods to prepare a phytosome: anti-solvent precipitation technique, rotary evaporation technique, and the third one is solvent evaporation technique. So let us now discuss in detail about each method. In anti-solvent precipitation method, what we are doing is we are taking a phytoconstituent, that is the drug, and we are mixing it with the soya lecithin, which is a phospholipid over here, and we are mixing this. This mixture is being kept under reflex with 20 ml of dichloromethane at 60 degrees for 2 hours. So once the mixture is being concentrated until we get 5 to 10 ml of the concentrate, and then to this 5 to 10 ml of concentrate we are adding 20 ml of hexane. And then after that, so what happens here is the hexane acts as a anti-solvent. That means the drug is as the drug is being solubilized in soya lecithin, afterwards the soya lecithin, when hexane has been added, the drug will be precipitated out. That is, the hexane and soya lecithin will combine at a faster rate, and then the drug will be precipitated. Now we are going to filter the precipitate, dry it, and crush and pass through the sieve number 100. So next, coming to the rotary evaporation technique. In this, we are going to mix the drug with soya lecithin, which is acting as a phospholipid. We are going to mix both the drug and soya lecithin in 30 ml of tetrahydrofuran, and then we are going to place it in a RBF, and we are going to assemble in a rotary evaporator. So this rotary evaporator is been done for 3 hours at a temperature not exceeding 40 degrees. So now after 3 hours, a thin film is being formed around the RBF. Now we are going to add N-hexane, which is a non-solvent, the example what we have seen in the previous slide. And now we are going to add this N-hexane with stirring. The precipitate will be formed, and we are going to dry the precipitate and pass through the mesh. The phytosomes will be formed. And the last method is solvent evaporation technique. So in this, we are going to add the soya lecithin with the drug, reflex with 20 ml of acetone at 50 to 60 degrees for 2 hours. We are going to concentrate the mixture until it is 5 to 10 ml, Now whatever the precipitate that is being formed will be dried and passed through the mesh. So these are the different methods to prepare a phytosol. So next, coming to the evaluation parameters, we are going to evaluate the complex that is being formed and complex formation and the study interactions between phytoconstant and phospholipids. We are going for spectroscopic evaluation, and drug content determination will be performed under the UV spectrophotometer, and the evaluation in vitro and in vivo evaluation will be done according to the therapeutic activity parameters. Next, entrapment efficiency also will be done by determined by ultracentrifugation. Vesicle size and zeta potential will be done by dynamic light scattering, and surface tension of that phytosomes will be determined by using the Dulnay ring tensiometer. Thank you.